Graphing f of x equals x plus 2 over x minus 2 all squared. We're first going to start off with a 0. So looking at the numerator, we have a 0 at x equals negative 2. So I've plotted that on my graph, and I've also put that in the table. And this table is just for me to keep track of all the different pieces I'm going to have for this graph. So that's the first thing. I'm going to have my 0. I'm also going to put in my y-intercept. So when x is 0, y is going to be equal to 2 over negative 2 squared, so 4. So it's going to be 1/2. And then I also have a vertical asymptote at x equals 2. So at x equals 2, I have an undefined value. So at 2, I'm going to draw in my asymptote here. So I'm going to look for some horizontal asymptotes, and I know I have horizontal asymptotes here because my endpoint behavior, I have a denominator that is power which is greater than the numerator. But I'm going to do this, and although this gives me the same asymptote going to left and right, when I look at this, I'm going to do just some sign analysis. And this kind of helps me understand from which side we're going to approach the asymptote. So if I plug in positive infinity, I end up with positive in the numerator. The denominator is always positive. So I'm going to approach 0, but I'm going to be approaching 0 from the positive side. So I'm going to be coming down. As I go from left to right, I'm coming down to the horizontal asymptote. Now, when I do the limit as x goes to negative infinity, we get 0 as well because the denominator is going to be infinite. But when we do the sign analysis, my numerator is negative. Put a negative infinity. My denominator is always positive, so I'm going to actually be approaching 0 from the bottom side, the negative side. So what that means is that it looks like when I draw my horizontal asymptote in, it's probably going to come up like this. So I should expect a minimum point kind of somewhere left of negative 2. So speaking of minimum points, I want to differentiate and get a derivative. I can do a slope chart. So f prime of x, that's going to be equal to 1 times x minus 2 squared minus x plus 2. And then differentiating this squared, I get 2x minus 2. And then I'm going to divide everything by x minus 2 squared. So x minus 2 to the power of 4. Now, when we simplify these things, we want to be aware of some shortcuts that we can help simplify these expressions. And I have a common factor of x minus 2. I have one here, I have one here, and I have one here. And that allows me to then simplify the numerator much easier than expanding this all out, combining like terms, and then we'd have to refactor it again to be able to get that common factor out. So this is going to be much easier. So the numerator becomes x minus 2 minus 2x minus 4. That's all over x minus 2 to the power of 3. And that simplifies to negative x minus 6 all over x minus 2 to the power of 3. Making this equal to 0, I get 0 at x equals negative 6. So then doing my slope chart here, I have negative 6. I have at 2. I have my undefined point. I need to test my slopes here. So testing my slopes, I'm going to end up with testing f prime at negative 8. Plugging negative 8 into here, I'm going to end up with negative, so positive in the numerator. And I'm going to end up with negative in the denominator. So that's going to give me negative slope, so I know I'm going down. I'm going to test my slope at x equals 0. I'm going to end up with negative in the numerator, negative in the denominator, which is positive slope. And on the other side of 2, I'm going to test my slope at x equals 3. I'm going to end up with negative in the numerator. I'm going to end up with positive in the denominator, so it's going down. So in this case here, my slope is pointing up on this side and up on this side. Now this happens when we have a squared denominator, or when I have my multiplicity in the denominator is 2. That's going to indicate that my asymptotes are my graph's going to point the same way on both sides of the asymptote. So at this point here then, I know that I have a minimum point, local min at x equals -6. So I'm going to put -6 into my chart. Okay, at -6, when I plug -6 into my equation, I get -4 in the numerator. I'm going to get -8 squared in the denominator, so I have 4 over 64. That becomes -1 over 16. And so at x equals -6, I have a point that's very close to the asymptote. So here I have all the parts I need to graph this then. I'm going to draw this along the asymptote. It's going to dip down to that minimum point. It's going to come up through here. I have a coordinate at 1/2, 0, 1/2. That's my y-intercept. And then it's going to follow the asymptote up in this direction. And I also know that it's going to come down from this asymptote, and it's going to follow the asymptote here. It doesn't have any zeros, so it's just going to look like this on this side. So there it is.